Hello everyone. Oh, good afternoon. Just. So, horrible photo. Let's get that one. So when I was asked for a photo, I just went, well, that'll be okay. Never did I realise it was going to be quite so big. So what do I do for a living? Many of the people in the room know me already because I get to use all your products and play for a living. And why do I do that? Well, I do that because I'm trying to find out what Inkjet can achieve to make stuff, the manufacturing part of this conference. So the idea is 6 years ago, I left a major ink manufacturer, bought myself a drop watcher, and decided that I was going to use that to try and find stuff out. And now I have 3 drop watchers. It's still only me, I'm just greedy. And each one of those is combined with a print system in order to not only figure out what jets, and we've heard a little bit about that from Zara this morning, but what prints and the process that's needed in order to turn that into a product. So I do use products from most of the suppliers who are present today. So I'm maybe a walking, talking advert for almost your entire ecosystem here. However, what I'm going to focus on is that process of getting from a material to the potential to turn it into a product. Okay, and this is a picture of my lab. I'm not very high tech in terms of where I am located. I'm in deepest, darkest Somerset. So, my lab is actually an old farm building, but it's the most high-tech farm building you've ever seen when it comes to the contents. So just to give a little bit of an idea, here is a rig that I will show you a picture of looking from this direction later, which is based completely on the Meteor drop watcher. Over here is a commercial image expert print station, my first investment, based on their drop watcher. And thanks to the kindness of a supplier in this room, this XY system I've been populating with my third drop watcher, which is also an image expert and inline. So why do I need so many drop watchers? Well, when you get involved in making stuff out of Inkjet, what you quickly learn is you either spend a lot of time with a screwdriver changing things over, or you need multiple installations in order to make meaningful tests on different materials in parallel, especially over time. Because reliability is a very key part of what makes Inkjet successful when it comes to making stuff, because no one wants to make rubbish, and we heard about that already. Okay, so you need to have a flexibility in implementation. So that's enough about the lab. What do I use it for? And what I basically use it for is finding out how to make stuff that's functional, and we'll define that in a second, into a part. So what does functional mean? Well, for me, when I started my career in Inkjet, I was printing OLED screens, okay, here in Cambridge, before I decided to run off to Somerset, back to home. And that function was an electrical function of emitting light. And I have to say, all the things I've done, it still probably counts as the most challenging manufacturing process I've worked on. But we've heard about wide format graphics, and to be honest, to make a big 5 meter wide, 3 meter tall graphic takes a combination of technologies that are evolved over the years in order to make this aesthetic possible. And I'm still impressed by that, regardless of the ink, the head, or a particular OEM. One project I worked on was printing keyboards. So instead of having to have stock of keys, depending on which language someone wanted, you just actually have a blank one, and then you print it. Now you think, okay, one thing, not much ink, so that's potentially not very interesting from an ink manufacturer's point of view, but actually quite difficult, particularly if you've got what my dad calls rusty fingers, because he plays guitar, so do I. I rust the strings on guitars because I have fairly moist hands, particularly when I'm stressed like I am standing in front of you lot. So when I'm typing on a keyboard, I pretty much take those letters off, despite the fact I have not really do a lot of typing. I mean, I write reports, but they're only a few thousand words. I'm not doing it all the time. So actually, functional can be the durability of what is effectively an informational print, one on a keyboard. I'm also not a touch typer, so I actually have to look at the letters. And when I wear the letters off, then I have to buy a new keyboard, because I'm not really sure that is letter S. And of course, that's a combination of properties. It's the optical density, like we heard about from Tsar, which makes it readable. It's the chemical resistance. Can I call it a chemical? I think I can, because I'm not a chemist. And then, of course, there's the function in terms of where I started, which was in light emission, like in this OLED display. Unfortunately, not inkjet printed. And then the mechanical durability. And this is a 2D print example for adhesion, but of course, when we look at 3D printing, as we've heard about already, that becomes the part itself. So functional is something you want to get for a printhead that's got to do a job that has to have some kind of oomph to it in defending its existence, usually. That could be light fastness. And in case of inorganic materials of the likes used in ceramics, often is. So moving on swiftly, let's get to manufacturing. What does manufacturing look like? Well, I've worked in a factory that looks like this on inkjet systems, and I've worked in a factory that looks like this on inkjet systems. Although usually they put the inkjet bit in a little house, so it isn't quite as dusty as the rest of a factory. So manufacturing means quite a wide set of things, even before you consider what the materials are, which in this case was a hot melt, and in this case was an oil with big rocks in it. So actually, what defines the function is what you need it for, but what defines the delivery of that function is the ink, or fluid, or coating. I will use the ink terminology fairly loosely. And, whoops, what you can see in these examples, all things I've jetted in my lab, is a difference between what happens if you're inorganic versus another type of inorganic, this being a oil, this being a UV base, and if you're organic. You might notice somewhat easier to manage. These have been probably sitting on the side of my lab for a year before I took this photo, which is why that one looks quite so terrible, and that one doesn't look great either. So functions about what you put in a fluid in order to deliver the property sought in the manufactured part. And printheads are a mechanism, a pump, a very advanced pump, for delivering that function in a form that's useful for that part. And the reason I have drop watchers is because I can look at drops coming out of a Samba printhead at something like, what is that going to be, 110 kilohertz, coming out of a Ricoh printhead at 70 kilohertz, coming out of, I can't even see what printhead that is. I think it's a Konica printhead at a lower frequency, maybe 12 kilohertz, but with some really massive drops. So printheads have a delivery for that function, and that function is so varied, as we've seen, that you need to have some equipment in order to optimize that. Or, if you've got a fluid, you need to be able to choose which printhead will do that job best for that fluid, so that you can inform the person who wants to make a manufacturing machine what can they use. And we've heard just about compatibility. That's a really important part of this, because function is usually delivered either by horrible chemistry that eats stuff, or it's delivered by big particles that block stuff. And it's about compromising the function to an extent that makes it manageable in inkjet. And sometimes that compromise isn't acceptable, and inkjet isn't the best way to approach the problem. And then once you've managed to deposit something on a surface, and I refer everyone to Marabou's stuff outside, which is much better than mine, it's about assessing that as fitness for purpose. So these are drops printing on glass, trying to replace moulding of glass in the production of bottles, so real manufacturing, although still technically decorative. And these drops are made by a Tsar GS40 printhead, and that's printed in about, in this case, about 7 passes. Now in high laydown you might be able to reduce that to a fewer number of passes, but that depends on what the customer already has and whether they can implement such new innovations. So sometimes there are constraints. when you're trying to introduce something to production, particularly if you're trying to make use of existing capital investments, you may not be able to take the latest, greatest technology and put that in, because that involves spending another few $1 million. And so I work within those constraints where I have to. But the key point of this slide is to say that once you've made something, you've got to test it, see that it's fit for purpose, whether it can be dishwashed 100 times at 60 degrees C, or whether it can be left outdoors for 20 years if it's something architectural, for example. So I already made reference to the fact that something icky and sticky and something that's got particles in it isn't necessarily a thing to jet. So sometimes we don't get the perfect drops that everyone likes to show when they're advertising their printhead. Sometimes we really don't get much in the form of drops at all. This is a particle in a solvent that has pretty much nothing else in it. It's a particle in solvent. The volatility of that at the nozzle means it actually growed sort of stalactites off the bottom of the printhead whilst you're trying to jet. That was being used actively in a manufacturing process despite that deficiency, because effectively they wanted the inkjet just to spray. It's still spraying, just not very well. And then on the end, a bit like the one I showed before, this is actually something failing because this is what it should be doing, this is a nozzle beginning to fail. Now what's intriguing is just how much volume it's managing to put out whilst failing. So all these things are things I look at every day in order to figure out, if I look at that and how do I make that better? Well, I can tell you one thing, take all the particles out, it'll be perfect. As an ink or as a fluid, and of course when you make a printhead, you'd love to put a test fluid in it and demonstrate it can go to 180 kilohertz, but the fact is, if you want to make something, what people are really going to do is they're going to put binders in it and they're going to put particles in it, and then it's not quite so easy to jet at 180 kilohertz. That's it in action. It's incredible. So, was I able to fix that? I'm afraid I wasn't. I am not a magician. When it comes to getting things into a printhead, then like I've said, I rely on the people in this room to make products that makes that possible in order to keep the printhead fed with those chemistries I can make jet. And so it's about building that system around the printhead in order to keep it working. And then it's about the process, which can be hybrid. So this is a graphic I did for Inkjet Insight in the US. It doesn't resolve as nicely up here because I expanded it a bit. A lot of successful processes, particularly in packaging print, are hybrid because you take the combination of the continuously variable data of digital, but you combine it with the proven reliability and functionality of analog printing. And that can be very successful. And actually that works not only in 2D printing, but works very well in 3D printing. So here's an example from my lab, using that rig I talked about earlier. It's a relatively short video. Fundamentally, I've got an ink system and a printhead driven by some software, a dryer by another supplier, another printhead, also happens to be Ricoh in this case. And what I'm doing is I'm trying to print this thin 2mm piece of metal, just to prove that you can, and that the resulting combination will go through the next part of the manufacturing process. So taking a jetting rig and turning it temporarily into a printer just to demonstrate that the ink can do the job. And unfortunately I can't tell you what the job was, or I can't tell you what the ink is. But, however, and what I can tell you is that Inkjet finds itself into lots of these different applications because of the combination of those materials with the target application. And as an example, to mirror what I said earlier about Marabou, this is actually not Marabou, this is one of their competitors, Zeller. For glass print, I did them a demo using their fluid and printing on this kind of whiskey-shaped bottle. The important thing here is the process. So this is what a print can look like before you've optimized it, and then by tuning things like viscosity, tuning things like LED pinning, refer to previous talks, then you can get more to something that's resolved. Why does that matter? Because when you actually want to demonstrate something that's visually appealing in order to sell your product, the resolution you can achieve matters. And I have two final examples coming up, and they both rely on the fact that inkjet precision also matters. My company name is derived from doing inkjet accurately, And you need to be able to measure that. So here's an example of two different distributions of drops from a printhead, just as a function of print height. So the engineering control of a printhead relative to a substrate is an important contributor to the success of manufacturing, just getting drops in the right place. That's what DoD exact means. Now to the manufacturing. And I didn't plan this, but thank you very much, Simon. So if we look at automotive, there are two ways in which inkjet have been successfully used. The first one I'd like to share with you, I've done inkjet binders in jetting. I don't reveal my clients, so I won't tell you whether it's for these people or everyone else, except it wasn't. And the interesting about this is being used by BMW in a production line to make castings. Absolutely incredible scale of inkjet-based manufacturing. Real engineering manufacturing. And we've already heard about this one, but because it was automotive, as the other one I thought of, I've jetted paints too. And they can be a bit tricky, particularly if they're not modified for inkjet. The rheology isn't very good. They sometimes got quite big particles in them. But what we're beginning to see is that the advancements in inkjet heads and the understanding of how to formulate fluids is leading us now more reliably into inkjet manufacturing, and that's across a range of industries. From the 2D printing that a lot of us in this room do, all the way at high speed, all the way through to customized manufacturing decoration applications. And that's it, all I wanted to talk about. Thank you very much.